Hi guys, so after a refreshing break, I am back at 9:13 in the evening. So let's continue with the explanation for the program I have done already. So I believe in the previous episode I have already done the this part where I explained in OpenCV there's a defined variable called size that measures the size of an object in width and height, which means respectively x and y axes in unit of pixels. Now, in OpenCV, there's a function to let us get the size of the drawing of text, which we're going to use later on here. But we'll get to that. So, a OpenCV image uses own format called a OpenCV mat. The OpenCV library will take care of the mat business, including capture image on the Raspberry Pi side, compress it to a JPEG, which then you can use to transmit, and then you can use the JPEG to feed it, and then let the mat read the JPEG, and then you can forward this mat to your screen, which is literally how this program works in the first place. Oh, not this one in particular, but the entire big finished program. Finally, in the end, right? So you give it the input, it can do its thing, and then mat become an image, and then you can get the image in whichever way you prefer, and that's kind of basically how it works. Okay, so it is an image, so we need to give it a size, and then we have this variable. So we .create, and then we can input the size. Keep in mind this is actually y, x, and then format, which kind of just means that, well, it's y, x, and then format, which means it's a reverse direction of what we normally see. Now that's something to keep in mind because it's a little tricky. Next, we're going to use std string text title and the std string text variable. Now std string is just string in C++, and these two are one for on top saying pitch, and one is a numeric display on the bottom showing you the actual value. And then, as I mentioned before, you have a function for you to enter the text string, the three font variables, and then I gotta check what the last one is. Yeah, so the last one is, oh my god, wait, no, bool bottom left origin. Yeah, that makes sense. Okay. So that just remind me that there are another change that I need to do to my program. But yeah, that's fine. It's a really small change. It's just like 6 characters. Okay. So we have a int line type equals 8, which get us. I think this is a segment count, but it can just be I think this option for anti-aliasing. That one sounds really nice, so I'm gonna try it. But if it doesn't, we can always fall back to a what is this? Hold up, just 1 second. Wait, no, this is. Oh my god, I did it wrong. That's this is a different function. Yeah, better. Okay. So get text size, and then we have a baseline, where the meaning for that is a output parameter y coordinate of the baseline relevant to the bottommost text point. Yeah, and then that is set to 0. It just means there are no offset for a baseline, which makes total sense. I mean, being honest with you, this one is what I've done like a while ago. I can still remember the test result, and I remember it works. So but maybe in another episode I'll try to see what's the different outcomes here, but not this one. I'm just gonna go through what I've done already. In this it's just one program, and then from that we can we can see what works, see what wasn't, and something we aren't so sure of. I apologize. We can just play around with it a bit, and we just see what happens, right? Now, text title origin, and so that's a. You remember I said there's a reserved space here, and the text should be right in the middle here. So we calculate that by this one, text title center, x-axis position, minus the text title's width divided by 2, which means that its center, text title center dot x, text title center dot y. Yeah, so the title text have length and width, and then if we divide the length by 2, we get something like this. And then so from center we minus that, so we can get the x coordinate of the original point. We're going to set the start from bottom left to true, so that a goes minus, and then it goes plus. So plus half the height and minus half on y-axis, and minus half the width on x-axis from the origin of the thing. And then that's the beginning of the text. Think what is the title saying? With the center, yeah. We define the centers here. So like this one is a width divided by 2, that's x-axis. It's right in the center. That's perfectly understandable. For title, it is the half of the reserved space, which means it's around here. And for the value, it's the entire height minus half of the reserved space, which makes total sense. If it doesn't make much sense to you, try to draw it out, and then it always helps, right? And then we have we record the size for the writing, so the size for the marking of the bars representing like that appears every 10 degrees. And then from that we can get you remember I said we don't actually say 359.9 degrees because that's a little, because it's not really like gyroscopic, yeah, it's not really a gyroscopic. It's not really a word, I just made it up, but you see what I mean. Because like the actual reading from your gyroscope could be like, I think 0 to 180, and then negative 179.999 to 0. Which means this, which makes perfect sense, and then this need to follow the feedback of the gyroscope. And that's what goes on here. And then so this one, if it is greater than 180, we minus 360, and then make sure it makes its way back up to 0. During programming, if you are unsure about something, you write logically, you write something down, and you go, hey, if I write this down, will the program do what I wanted to do? If this is the case, I personally always find it useful to actually go through the entire logic like a computer. I mean, you are not going to be able to do it as fast as a computer, but just pick some samples and then like especially boundary values and go through it like a computer. And then from that, sometimes you are able to realize, hey, I did this right, so it should be no problem. Or, hey, I see what's going on here, I did this wrong, and then you are able to fix it. Now, it is totally fine if you are not able to do that, if you like didn't really get some proper results out. That's perfectly fine. You can still go to a debugging stage, and then you can still go say, this is a little problematic. I debug it a bit. Hey, it works now. Like that's still perfectly fine. But just if you are not sure about it and you would like to be sure, it is sometimes a good idea to go through your logic like a computer. So for example, it is smaller or equals to 180, which means so if that is the case, we go so 170. So if I equals so I is 0. This one I times 10 is 0, smaller than 180, so that's true. And then size bar value I, so it's the first value. Remember in C++, array starts at 0. Always remember that, elsewise you might get a memory overflow, which is not something you want, okay? Memory management problem in C++ is kind of a big one and a tough one for most of the beginners, including me. And like even for some of the experienced worker working with it, if you're not very careful with it, like array is kind of fine. Just always remember like the professionals and the people who are used to it, the experienced people, like I can do that now. Like we always remember it's starting from there. Of course, I'm not actually experienced people. But I have a little bit of experience and I'm able to remember that. That when you work with it for like a few months, you'll be able to remember as well. But the tough thing is pointer, but I'm gonna deal with that later on when I'm talking to you about the IPTCP and I'm sorry, and IP-UDP communication protocol, which will have a lot of pointers involved. That one's really tough. Like the real professionals, the real experienced people who knows how to deal with it. I kinda, but I don't really. I need to do some experiments to actually see if everything flows properly. And that's perfectly fine because I mean like I'm not really an experienced professional right now, right? Come on, man, I'm 16 years old. Right? But yeah, I suppose I do want to be though. Right. Yeah. No, that doesn't sound good. Yeah, so it's always a good thing to remember that in C++, array starts at 0. Now, and then for Z, so if we go 0, we get 0, and then get size of the tags. This one is to convert a integer to text. So we go itoa I times 10, so 0 times 10 equals 0, and then the text is 0, font face, font scale, signals, and then 0. So it goes here. If we go 170, this one is a 17, which means it is the 18th component in the array. We have itoa I times 10, which means 170 font face font bar. So writing will be 170. That's perfectly fine. Now if we go to 180, which is a boundary value, we'll have 18 here, which means it is a 19th value, which is the correct one because remember it starts at 0. And then we get text size itoa I times 10. Which means we write 180, which is still perfectly fine. And then we go to 190. We go to 19, it's 190. 190 is smaller. Is 190 smaller than 180? No, it isn't. So we go to else. And then size by value I equals get text size I to I times 10 minus 360. And then if we do that, I times 10 is 190 minus 360, which will give you negative 170. And that is the correct marking for the position. So if you go through like a computer, you can eliminate some problems sometime, which is kind of useful. Now let's keep going. Yeah. So do you remember I said this is an experiment and I'm going to turn this into a header later on? I'm not sure did I say it today in the previous session or did I say in yesterday in a video I deleted. And that one was because of the audio quality back then is a little undesirable. So I deleted that one. But yeah. So anyway, this thing is an experiment for a header I'm going to write later on. And because of it is because if it's going to be a header, there will be multiple functions that allows that to construct to a certain purpose, which means that we can actually separate the stuff that only need to be go through once from the stuff that need to be gone through every single time things refreshes. And these ones are the static stuff that only need to be going through once. The advantage of doing this will be that you will save processing power when you do not need them. And then that way you are optimizing your program, which is always a good practice. But don't when you are facing a decision to make, think about it. But if they are just between saving the processing power and not saving the processing power, it's always a good idea to save the processing power. Right? Excuse me. It's gonna sound really weird, but it's a fixed term relationship? Yeah, I'm with someone. Okay, what does Chantel know that you don't? Okay, man, it can be literally anything, okay, like video gaming, or something related with computer, something related with programming, something related with security. Even ask her to help you pick a lock, okay? Okay, man, it can be literally anything, okay, like video gaming, or something related with computer, something related with programming, something related with security. Even ask her to help you pick a lock. Okay. I mean, come on, man. I mean, these stuff are kind of public. I mean, I'm pretty sure you know these. Just you can ask her to teach you anything, or even pretend you don't know something just to ask her to teach you. Sorry, man. Once again, I know I'm not in a position to give advice, but I mean. Yeah, I mean, we became friends, and that's literally how, so we can expand our imagination, but can't we? Right. So, yeah. So they're saying we're going to a function called initiation, init. I normally write it as void init and then some parameters. But everyone has their own habit. Some people just write it in the general creation function of the class. There is always one. I think it's called constructor. The one that doesn't have a return value. You know. I mean, it's personal preferences. It's totally fine however you want to do it. Okay. But once we get to network programming, network connection, you see why would I like to actually just write init. Now these ones are my train of thought. Alright. Now think about this. So this is what I'm gonna do. So this is what I want, and then so I know what I want, and I think about it. How can I make it work? What process does it need to do? Does it need to go through to actually have something to actually produce me that one outcome I want? which is a photo that's going to go on my screen around somewhere around here. So you think about it and you write it down. Now, I mean, you don't have to, and you can write it down in a separate document, it's perfectly fine. But in this case, I just write it down in the middle of my program, which is still perfectly acceptable. Okay. Your compiler is just gonna go straight through this one, ignore. It's not gonna care about it. It's not going to affect your program at all. Okay. I'm not sure will it in Python, but in C++ it just doesn't. Okay. So this is where it will work. We know how many pixels are there to represent 80 degrees, which is this height minus the reserve height minus reserve height, which means height in the middle, right? Which is designated amount to fit into the pitch HUD. We can then figure out how many pixels represent each degree, because we already know that it's 80 degree and this many pixels, which may be a decimal, which it turns out it isn't. And after calculation, after I find out it isn't, I decide to put it as int instead of float. We can find out the center of the mat, which will be a non-zero numeric value. Since the location of the mat is scalar, that represents the 0 degrees, since attitude is vector. Yeah. So you will be having somewhere around here that when your attitude is 0, the 0 mark on attitude will line up with your pointer's triangle here. And then because of attitude is a vector, it goes negative up, so negative 10, negative 20, negative 30, and then it goes positive down, so positive 10, positive 20, positive 30. Oh my god, what did I do? Okay, positive 30. And then, so then we find that center point, which is right in the center here, right? Because of the top reserve space and bottom reserve space is the same, it's still the center, right? Which that represents the 0 degrees, since attitude is vector in real life. We can use this value plus a reading back to pixel from degrees. And then so if your reading is positive, the entire scale will goes up, right? Which means that the actual location of 0 will be this place minus the pixels that represent those degrees. And if the value is negative, so like you are slightly doing this, then it will go down. So it's a 0 value plus the pixels representing these degrees. Now keep in mind that this is the center. No, this is 0 in this mat, okay? And then when it goes down this way, when it goes down like that, when it goes like down, the y value goes up. So when it goes down in pixels, y value goes up. Okay, so it's a weird concept, okay? It's a weird concept, but it's how it works. Right? And then something to keep in the back of mind. I mean, these ones will also have another advantage. So when other people is maintaining your code, when other people look at your code, when you look at your code like from a year ago, you will look at this and then you realize, hey, this is what I was thinking. In case you forget, or in case other people doesn't understand your code, they will be able to go, or you will be able to go, hey, this is what he or I was thinking, and then this is how I planned it to work. And so you can review your code, and then everything just makes more sense, right? And then it's a note. I've left heaps of notes in here for you guys, like in case you guys need it, right? So something to keep in the back of mind. In an application like this, on good laptop or desktop, because of like this one actually doesn't use that much processing power, like a good Intel Core i3 or even Pentium, like 6th generation or later, Intel, I'm not sure how Ryzen perform, but I think it's gonna be kind of similar. I mean, in a modern processor, this program will be run so easily that nobody will think it's a problem, right? So in an application like this, on a good laptop or desktop, you probably have all the processing power and memory you need and you want to run the process however you like it, right? So even if you do a bit of a waste of processing power on something or on this, on that, or a bit of a waste of memory, you still get by. The program still runs at the frame rate that you want, okay? But always keep in mind that this is a limit that you cannot top, because your processor have a limited processing power and you only have that 4 gig, 8 gig, 16 gig of RAM. I'm sure that out of one or a few of your audiences, you will be having 32 or 64 gigabyte of RAM laptop. But yeah, but normally I think it's 16 tops. Like, yeah, most of the laptop goes 16 tops, like the laptop that normal people will buy. If you're buying a gaming one or professional workstation, it might goes up to 64 or 128, I think. Laptop 128. I mean, I'm not gonna get any of that. It goes up to 16 tops. On laptop, on desktop, I'm aiming for 48. But I don't have one yet. I might get one when I actually need the I might actually get one when I need to process CFDs that my laptop cannot process. Yeah, yeah, but that's a story for tomorrow. So always keep your mind that there's a limit you cannot top. And I mean, honestly, it's hard sometimes to learn this without learning it the hard way. So like, I can tell you, keep that in your mind, keep this in your mind, keep that in your mind, but like, sometimes you just forget. And then sometimes things come back, backfires and come back to bite you in the A term. And then you realize, hey, I did this wrong. This is a mistake I made. Oh my god. Yeah, I mean, in software, that's kind of okay. But what I actually mean by hard way, I learned this the hard way, is because of once I designed a circuit board that doesn't have enough processing power to actually run my code. And I mean, like and then my code, the code I write back then was still that was more than a year ago, I think. That was more than a year ago. The hardware that was a bit less than a year ago. A bit more than half a year ago. And I mean, my code was not to the best efficiency, but it's nearly there, and I didn't consider hardware capability while I'm designing the actual hardware, which in the end caused my entire circuit to just not work at all. And that's what I actually mean by learning the hard way. So try not to be like me, okay? Like in the bad way. In the good way, I'm happy to be a role model. I'm just kidding, I'm not that good, but yep. Int scale height, pitch display height minus 2 times pitch display title height. So this is pitch display height, and then you have reserved space on top, reserved space on bottom, and then the actual height of the scale is going to be right here in the middle in the core, and then that's what you see here. Makes sense, right? And then you can calculate how many pixels is there a degree per degree. And then you have the scale height divided by shown range, which is still calculatable. Yeah, I left it as double. I'm gonna change it to float. I'm just gonna change it to float just in case, but I think it's gonna be an integer. But in case somebody wanna mess with the resolution a bit, or maybe I wanna mess with the resolution a bit, or maybe I actually build myself a hardware controller instead of using my laptop to fly it. It's gonna be useful to keep us afloat, so let's go with float. And then we have the mat cylinder, which is right in the middle over here, Yep. And a pixel. By the way, mat cylinder is it's not a XY coordinate, right? It's a y-axis cylinder to actually draw the triangle. And then we have pixel between marks. So you know that's 10 degrees. You know how many degrees is in. You know how many pixels is each degree, and then so you can times that by 10, where I did a different way here. So you have the you know that you will have 80 degrees in the middle here. So you have a distance in pixels in the middle here. So you can get that divided by 80. So you have like 80, it's like 10 degrees per mark, so that's like 8 marks. And then you have this height divided by 8. So you get pitch display height divided by 8, right? And then we're up to step 3. So it's always a good idea to keep the record. Yeah. And then you have a degree to above and degree to below. So you have a triangle here representing your current reading. And then you have a reading here, right? And then you will know how many degree is this to the 10 degree above it, and how many degree is this to the nearest 10 degree below it, right? One second, I'm just checking if I wrote my code wrong. Yeah, I think I might have wrote it a little wrong. I will take a break here, and I'll see you guys when I'm back. I actually think I might be done for today. I mean, it's nearly 10 o'clock, so yeah. See you guys tomorrow.